Okay, for number 11, it says find the rectangular coordinates of the points on the Lima scan, which is r squared equals 81 cosine 2 theta in the figure. We'll look at the figure in a moment. At the points where the horizontal potential, let's see if we can do that. Let's take a look. R is greater than or equal to 0. Let's take a look at it. And this is the picture. And I see two places immediately where I'm getting a tangent that's going to be vertical. It's right here. And one is right here. All right? Now they want the R to be positive, and just kind of take a look at it. And I'm going to say that, I pretty much, I think I know what it is, but I want to point out what I mean by that. I think this is when the theta is equal to 0. Right, let's write that down. So r squared, we'll get the point in a moment, 81 cosine of 2 times 0, which is 0. All right? Now, let's be careful about that. And what am I doing over there? Cosine of 0 is 1, so r squared is 81. So now I know the r is going to be plus or minus 9. Let me put the point down. And what's the point going to be? Well, I'm looking at that one, a Cartesian point, and the r is 9. Looking at my picture, if the r is 9, that means the x is 9. And the y is going to be 0. I see a good deal of symmetry over here. Let me write this one down. What's it going to be? Well, minus 9, comma, 0. And again, we're putting the points down, x, comma, y. Now, these are more challenging over here. There's going to be 1, 2, 3, 4. Now, before I do anything, I want to point out there's tremendous symmetry in the problem. I think if I can figure out one, I think I can figure them all out. Now, if you were to graph this thing out, all right, and what I want to do is I want to graph out r equals, I'm just going to look at the positive thing, 9 square root cosine of 2 theta. I'm not too worried about taking points over here. What I do realize is that as I start, starting off at 0 and I start moving through this thing, that I'm going to get something that looks like this over here. Moving up, something like this. Now, what I want to do is I just want to talk about this, the first loop of this thing. Maybe I shouldn't say loop, this first section over here. I want to talk about this thing over here. And I'm saying, it's starting at when theta equals 0. And then over here, I'm thinking about what happens over here. And that would be what? I'm going to say pi over 4. Let me just go through that with you. Again, I'm looking at this point now. Right? I know this point over here. I'm looking at this point. And so let's write this down. So r equals 9. It's going to be the square root of the cosine of 2 times pi over 4, which is pi over 2. All right? Now, someone says, you haven't even taken a derivative yet. I haven't. I'm just kind of analyzing the picture at this point. And what am I seeing over there? Well, let's think about it. Cosine of pi over 2 is 0. Square root of 0 is 0. So r would be 0. So this makes sense. Right there. All right? So I know whatever this point is over here, it's somewhere between 0 and pi over 4. All right? Let me get my eraser out, and I'm going to start to erase things over here that I don't need anymore. I certainly don't need this. Let me see. I don't need this. I got the point there. Let's see. I really don't need this business here anymore. I got to figure this out over here. What I know about, there's a horizontal tangent line over here. Let me just get my eraser out too. I'll erase this over here. So what I know about this over here, there's a point here. I don't know what the point is, by the way. But I do know the point somewhere between, the x value is somewhere between 0 and 9, and the y value is certainly unknown to me at this point. But look at the picture. If it's properly scaled, I could probably guess at it. So what I got to do is I got to get the derivative. And I've got to figure out where the derivative is equal to 0. So really what I'm looking for dy dx, right? I'm looking for this. And the question about this is, what am I looking for? When is this thing equal to 0? What value of theta would produce a 0 there? I got to get the derivative first. And the way I'm going to do that is I'm going to just, certainly just talk about this region over here. That's all I'm talking about. And I'm just going to write down r equals. It's actually a function of theta. I'm just going to use the positive part of it. I'm going to say 9. And then it's going to be the square root cosine 2 theta. All right? Now, granted, we've gone through this before, and I certainly want to go through it again. But I'm going to say r is a function of theta. Let me write this over here. R is a function of theta. And what's that function going to be? At least for this region over here. What I mean by that, we're just talking about between 0 and pi over 4. It's going to be 9, and then I'll put down cosine 2 theta to the 1/2 power. Let me write down f prime of theta. All right, and what do you get there? Well, it's going to be 9/2. I'll clean it up in a moment, by the way. Then you're going to get cosine of 2 theta. Take a 1 from 1/2, you get minus 1/2 times root of the inside, which is going to be minus sine. I'll put that over there. 2 theta times 2. Let me just clean it up a tiny little bit. And f prime of theta, I'm going to say minus 9. I can put the square root in the bottom, and that's square root of cosine of 2 theta. And then I get sine of 2 theta. All right, and then what I'm going to do is, once I get this over here, the next thing I'm going to do is, pop it into the formula that we've done before. And what form are we talking about? This one over here. All right, this is neatly typed up. And before I say it's neatly typed up, I want to remind you, we know what f of theta is. I'll write this over here. R is f of theta. These are two things that I do know, at least on the region between 0 and pi over 4. And I know the derivative. I just did it, and that's going to be minus 9 cosine 2 theta. I'm sorry, I made a mistake there. Sorry about that. It's minus 9 sine 2 theta over the square root cosine 2 theta. Right, and then I kind of pop in the formula. I want to point out that I have it typed up, and I want to just go through what I'm writing down over here. So the first thing I do is what f of theta is. It's 9 square root of cosine 2 theta times cosine theta minus, that's the derivative right away, 9 sine 2 theta over the root of this sine theta. What goes on bottom? F prime of theta, I got this over here, times the cosine of theta. Again, we're just using that formula there. Let's see, minus f of theta times this. Now, someone says, well, what do you do now? And again, it's up to you, but I think I would multiply top and bottom by the square root of the cosine of 2 theta. And the reason it looks like it's going to work out pretty nicely. Oh, by the way, you know what I'm also going to do is divide by 9, top and bottom. So 1/9, 1/9. All right? So what are you going to get? Well, if you do the top, you'll certainly get, cosine 2 theta, because the root of cosine 2 theta times the root of cosine 2 theta is the root of cosine 2 theta. The 9 disappears, and then we get the cosine theta. We get a minus sign. And then that fraction disappears. The complex will get, the 9 disappears. So we get sine 2 theta, sine theta. We'll take care of this later, by the way. Let's keep going. Let's go to the bottom. What do you get? Let's see, the 9 disappears. The denominator of root cosine 2 theta disappears. We're left with minus sine 2 theta, cosine theta. All right, then what do you get? Well, the 9 disappears, right? You still got my subtraction. The root of cosine 2 theta times the root of cosine 2 theta is cosine 2 theta sine theta. This worked out pretty nicely, all right? And, certainly looking at it, I don't know, maybe just make it a little bit easier for me. Multiply the top and the bottom by -1. And the bottom you just get, sine 2 theta cosine theta plus cosine theta sine theta. Now someone says, I wouldn't have done that. You don't need to do that. I'm just saying that's not a bad thing to do. If you do the top, you get sine 2 theta sine theta, and then you get minus cosine 2 theta cosine theta. All right. Now granted, it might be in a distant memory to you at this point, and it could be. Like you say, I just went through all that work. I don't even know why I did all that work. You did the work to get a derivative. Let me erase all this business over here. I'm pretty much convinced that I got the correct derivative. And what are we talking about? At the very end of this is dy dx. And I want to remind you again, going back to my original analysis, I'm looking for this point, and I know it's going to occur between 0 and pi over 4. All right, and that's an important fact, by the way. So I know my theta is between 0 and pi over 4. I don't know what it is, but I know it's between that, 0 and pi over 4. Looking at the bottom, I want to get a horizontal tangent. So really what I'm left to deal with now is, I'm wondering when this becomes 0, provided the bottom is not simultaneously 0. So let's take a look at it. So let me write this down for you. So for the top to be 0, it would mean the sine of 2 theta. Again, my thetas are between 0 and pi over 4. Times the sine of theta. And again, for this to be equal to 0, I want this to be 0. That means this over here has got to be 0, provided the bottom is not simultaneously 0. The only way the top can be 0 is if it equals the cosine of 2 theta times cosine theta. Let me see if I got that written down right. Sine 2 theta, sine theta, let's see, cosine 2 theta. Yeah, like that, okay. I'm going to keep rewriting it because it looks like a tough equation to solve. And if everything is sine 2 theta is 2 sine theta, cosine theta. I got a sine theta there already. And so I'm not too worried about the cosine 2 theta. Now, one thing nice about this over here, if I'm between 0 and pi over 4, the cosine of theta is not 0. So what I can do is I can divide both sides by that. It makes it substantially easier for me to look at. So what do you get? You get 2 sine squared theta equals the cosine of 2 theta. Well, there's plenty of identities for cosine of 2 theta, and I'm going to write this one down. 1 minus 2 sine squared theta. All right, let's see how I did with that. Yeah, I think I did it right. Right, because cosine 2 theta is 1 minus 2 sine squared theta. Let me add that, the 2 sine squared theta to both sides. You get 4 sine squared theta is equal to 1. Things are definitely getting easier. I'm not saying I'll be able to do this, but let's take a look at it. Let's see. Let's see what I got here. So sine squared theta is 1/4. Let me repeat this again. We're between these two numbers over here. So the sign's got to be positive between us. So what do I know about this? Sine has to be equal, not to plus or minus, by the way. It can't be negative between those two numbers. So I'm just going to say 1/2. Boy, that really simplified to something that I think I can handle. And let me just write down this. It looks like a nice, easy, reference triangle that I've seen before. This would be 1. This would be 2. This would be root 3. It's certainly a very memorable one. This would be 30 degrees. 30 degrees, by the way, is going to be equal to pi over 6. So my claim over here, let's go back over here. that this point here now occurs when theta equals pi over 6. All right? And let's go back and write our points down. So I want to claim to you we have this point here. That's good news. We'll check in the key later. This point over here. That's good news. I want to get this point over here. All right? And how do I do that? Well, I guess I got to know what the graph is, right? The graph is, r squared equals 81 cosine 2 theta, right? So what's x equal to? Let's write this down. X equals r times cosine theta. Y equals r sine theta. All right, let's see if we can do it. And what do I got over here? I guess I got to write things down, right? So let's just do the r first, all right? I think I want to get my eraser out and start to erase things that I'm kind of done looking at. Kind of done looking at this. And let's see what else I'm done looking at. Yeah, think about it. Most of it I'm done looking at. Let's write this down. So r equals 9 square root. By the way, I'm looking at this to write this down. Cosine of twice theta. And this is what theta is. That's going to be pi over 3. And pi over 3 is 60 degrees. So I'm going to say it looks like this over here. And that's going to be root 3. This is going to be a 1, and that's going to be a 2. So that's going to be, 1/2 and the square root of 1/2. All right, let me write this down. So the r here is going to be 9. And again, the cosine of pi over 3 is 1/2. So it's really the square root of that. So 9 over root 2. Let me write this down. It's going to be 9 over root 2. 9 over root 2. Now what I got to do is I got to do the cosine of theta. This is theta again. And remind, that's 30 degrees, right? So it looks like this over here. 1, 2, root 3. Okay. We have to write it down now. Cosine of theta is root 3 over 2. The sine of theta is 1/2. So what do you get here? 9 root 3. On bottom, you get 2 root 2. I'm not really worried about rewriting these things so they look neater, but I'm going to say the best I can do. 2 root 2, and then the top is just 9. All right? So what's this point over here? Well, let's write it down. It's going to be, there's so much symmetry, it's almost ridiculous. Let's take a look at it. The x is going to be 9 root 3 over 2 root 2, and the y is going to be 9 over 2 root 2. I think I can write this one down with little to no work at this point. All right, what's the x-coordinate? Well, it's going to be 9 root 3 over 2 root 2. Oh, if these numbers are wrong, every point I'm going to write down is wrong now. So what do you get next? Well, the y is going to be negative, so minus 9 over 2 root 2. Let's do this one over here. Relatively simple. What's it going to be? Well, the x-coordinate is going to be minus 9 root 3 over 2 root 2. And the y-coordinate is going to be minus 9 over 2 root 2. What's this point over here? Let's see, minus 9 root 3. We'll check the key in a moment, by the way. 2 root 2, comma, 9, 2 root 2. I think I'm done. I want to look at the answer key, by the way, and I'm going to recommend you do that as well. And let's just see if I've written things down for you. I'm going to make sure I'm writing things down. We get this over here. And so I'm not going to read through the whole thing, by the way, but I got to, move around and see if I can figure out what they just said. I'm kind of reading through really kind of quickly, not aloud though, by the way, kind of just staring at it. Boy, a lot of stuff is written in there. let's take a look. Oh, I see this. Vertical tangents at plus or minus 9, 0. Let's see if I wrote that down. Yeah, right over here. I got these two done. Bingo. All right. I won't do the analysis in this way. It'll kind of work, but I want to see if I got, oh, you know what? They did some simplifications over here. So what I want to do is I want to write the numbers that I was writing down. And what number did I write down? I got to remember. I'll just, I know there was a pattern to it. So, 9 root 3 over 2 root 2. I'll put that down. And the other number was, 2 root 2, and I believe a 9 was there. Let me just see if I said that true. Yeah. They wrote a little differently, though. And someone says, why is that? I don't know. Maybe that day I felt writing different. So I would multiply this by, root 2 over root 2. What would you get there? You get 9 root 6, and that would give you 2 times 2, which is 4. I'd multiply this by root 2 over root 2. You get 9 root 2 over 4. All right? So, I'm looking for these points. And what am I looking for? Plus, plus. All right? So, I know I'm scrolling a lot here. I got this one covered. This point over here. Where did I write that point? Right over there. All right? And then I'm looking for, plus, minus, 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 and minus, plus. Let's see if I got all 4 of those. All right? So let's see if we got the minus, minus of that. Let's see if we have the minus, plus of that. And again, great symmetry with these problems over here. And then the plus, minus of that. And again, we're getting that from looking at the symmetry. All right, I know it's a tough question. I realize a lot of times this thing, I can get confused and lose track. What's nice about it is an answer key, which really kind of lends to the belief that answer keys are nice to have. And certainly multiple choice exams, which a lot of students will fall into that trap of being given a multiple choice exam, that's the answer key, right? What are you looking for? The correct answer, of course, right? And certainly I followed the information given in the problem. I put on the graph. I saw symmetry. I did some tricks along the way, by the way. But 11's done. We're good to go. Next question. Thank you.